Hello, in this video let's discuss second question of today's contest. Given two integers n and k, split the number n into k different k positive integers, exactly k positive integers. They can be same or different, such that the product of these integers is equal to n. Return any one split in which the maximum difference between any two numbers is minimized. You may return the result in any order. So given n and k, we have to split n into k different numbers such that the maximum difference between any two numbers is minimized. The conditions are n is up to 1 if I and k is only up to 5. K is strictly less than the total number of divisors of n. So it ensures that we always get an answer. So simply split the n into k factors such that the maximum difference is minimum. So what is the maximum difference between two numbers in an array? It is simply between the maximum element and the minimum element. So the conditions are we already discussed. So first thing is, as k is very small, just try all factors, and at the end we can think whether this is the best answer or not. So let's do a dry run. So let's assume that the n is 100, the number is 100 and k is 2. So we have to split 100 into two different numbers. So these are the factors for 100, 2, 4, 5, 10 and so on till 100 again. So let's start taking the first one. So let's assume we are taking 2 for now. So the first one is filled with 2, and then the second one is blank because we did not decide it. So let's continue this. Let's find what is the possibility. So we came to this side. So initially n is 100. So now we selected 2. So what will be the new n for the rest of the array? It will be 50 because for 100 we already selected 2. So the rest of the product should be only 50. So new n is equal to 50. So this is 2 and this is 50. And now the k is completed. So we got two numbers in the array. So for now let's assume that as this is the first answer we got. This is the best answer so far because till before we did not get any answer. This is the first case we are deriving. So difference is 48 and this is the least till now. So initially assume difference is equal to int max. So this is the least till now. So the answer for now is 250. So we completed this case. So for starting with 2, is there any other possibility? No, because the product should be 100. So only 50 is the possibility. So we completed this case. And now let's try second one. So the second one is 4. So start with 4. So then try to fill the next one. So now it is filled with 4. So what is the new n? It will be 25, which is 100 by 4. So it will be 4 and 25. So now what is the difference? We reached the end. That's why we are thinking about the difference. Else we again went through the factors of the remaining number, and then we will go to last till. We will go till last. So we reached the end of the array. So we are thinking whether this is the best answer or not. So now how to find whether this is best answer or not? So simply find the difference between maximum and minimum. So what is the difference? It is 21. So difference before is 48, but now it is 21. So this is the one we want. So make this as answer. So currently the answer is 4 and 25. So we complete this case also and come to 10. We are just simply trying and checking how the flow is going on. So now we are filling with 10, and then what is the next space? What is the new n? It will be 10, which is 100 by 10. So this is the new array. So we came till end of the array. So now check the difference. So what is different? It is 0. So this is better than the before one, which is 21. Obviously yes. So then update the answer. So answer is 1000. So in this way, as k is small, let's try to fill the values accordingly. For example, we have 100, right? And now for let's assume k is equal to 5. So we have 5. So what are the devices? What are the factors? 2, 4, 5, 10. And the rest are 100 by these numbers, right? 100 by 10, which is 10 again, 20, 25, 50. So let's fill the first one with 2. And then we still have 4. So this is exactly like the original problem, right? But only n is reduced n by 2 because we considered 2. And k is also decreased because the new size is k minus 1 because the total size should be k. We selected 1 for now. So for rest of the array, what is the numbers that to be selected? It is k minus 1. So only these two changed, right? N by 2, k minus 1. So this is exactly a new problem where we have new n and k. So this is exactly like recursion or backtracking. Recursion simply. So at a given possibility, we have many different choices. We can have 2 first or 4 first or 5 first or anything. So let's select one and then think of the rest of the array. So we will complete the rest of the array for this case, and then we will update the answer if the maximum difference is less than the before one. So we will update, and then we will start thinking about this. We will complete the whole possibility, and then we will update the answer again. We will go to 5, update the whole array recursively, and then we will find the answer. So n will be updated every time when we take a factor representing index. So for function, what are the thing states need to be maintained? It is n, because if we take a number, the n for the rest of the array will be n divided by the present number we selected. So n is the updated thing. So we have to keep as a parameter, and then we have to track k also. Else how can we know whether initially our requirement got or not? Because initially it is given that k should be done, but without maintaining k, how can we make sure that k numbers are exactly taken? So k also must be maintained in the parameter. And then, so for example, let's think about function. So what does the function should return? The function originally should return the array, not the difference, but we have to return the array. So should the return type of this be vector, as we have to return the vector? No, because it will be difficult, right? So we have to track the minimum difference also. We have to track the minimum difference, we have to track vector. So returning vectors from function may also be bad. So what can we do now? So in this time, in the situations, we can just try to use a void function, and then we can use the parameters as call by reference parameters, so that indirectly it is like returning, but we are updating in the parameters itself when we are calling the function. So for example, we have function of big vector, right? Let's say we have function of vector. So and we are returning vector of int function, function1, and function2, which is just using a parameter. Which is better? So obviously second one is better, because here we have to make sure that we are returning correctly. But here we will only update the parameter. So simply accessing the parameter is fine. But here we have to return something, we have to return a correct vector. So this is slightly more difficult. So in this way, if we try to use a call by reference, we can directly update in the vector itself, and then we can access in the just parameters, but by not using any return type. So just use void function with the parameters. And also we have to track a answer vector. We have to maintain the current vector where it is the current one. For example, the answer is 250 till now, answer is 4 and 25. So 10 and 10. So where this will be stored 10 and 10. So a new vector will be required. So this is the required vector, which is current, and this is the answer vector, which is the answer till now. So we want two other vectors also. One is the current vector that is going, and the other one the best answer so far. So these two are also the parameters, current and answer. And also we have to get the minimum difference, else we have to find the minimum difference in answer again, which will be into 5 complexity, right? Because size is 5, so time complexity may be multiplied by 5. So simply, instead of doing on answer again, what if we try to maintain a single parameter minimum in the parameter also? Then it is very simple. So we will find the, so if we reach it end, we will find the maximum minimum difference in current. So let that be x. So if this x is less than minimum, then we got the answer. So update x in the parameter and update answer also, right? So if it is not, then simply return, because there is no need to do, because the minimum is not now, so it is already completed before. So don't destroy it now. So in this way, by maintaining these globally or call by reference, we can get the answer. So let's check code. So now let's do other small trial, right? So for example, k is 100, n is 100, and the k is 3. So what are the factors of 100? 2, 4, 5, and 10 for now. Other all just the mirror factors. So let's assume the first one is 2. So if this is 2, the current is 2, right? Because current is initially is empty, because this is the first one that we are selecting. So it is 2. And then we have to fill the rest of 2. So just call recursively. So don't think about recursion now. So we are at this position. So for example, we are at this. We only added 2. So after calling recursion, think of only this again. Don't think about the second parameter now. So don't start thinking about 2, 2 again. Because let's think only about one level. The recursion will take care of other. So we are at 2. So just think about this. So just think about this 2. So we call the recursion. So this completed, and we came to this again. We came to 2 dash dash again. So after completing recursion and coming to this, what are the things we have? We have an updated answer because of new flow, because of a continued array, and we also have a new minimum, right? These two are already updated. So we got the answer when starting from 2. So our job is done. So no need to think about the second layer, about 2 2 or 2 4 or 2 5 and so on. So our main goal is to find the answer starting from 2. We already got that, right? By recursion, we already stored that in the parameters. So when we are reaching 2, we already got the answer, we already got the minimum. So don't think about future. So just call the recursion and that's it. So the answer for this is computed. And now start for 4 because this is the next one we want. So start for 4. So here it is 2. So the current is 2. So in the recursion, we will pass the current as 2. Why? Because there is a new vector, right? And now 2 is the current vector. So that we will pass in the parameter. We got this answer. And now let's start from 4. So for 4, what is the new vector? It is only 4, right? Because we are thinking about only 4 now. We got all the answer for 2. So 2 is useless now. So just simply remove 2. We only want current in 4. But in the while we are doing for 2, we push 2 in the current, right? Because current is equal to 2 then. But now current is equal to 4. So we have to remove the back one. So we have to pop back and then add the present value. So we have 2, 4, 5, 10. Initially current is empty. We came from 2. We came to 2. So add, so current dot push 2. So just push into this because we are assuming the present factor is 2. So we will do this and we will call the recursion. What will be the new state? It will be n by 2 k minus 1 and so on, which will be current, which will be answer and so on. So after this, so when we are coming to this position again, so recursion is already completed. So we are at new. So what we have to do? We have to just pop back the 2. Why pop back? Because for when we are considering 4, the current should be only 4. If we do not pop back, the current will be 2 in 2 comma 4, which is bad, which is wrong. Because we are considering only 4, so it should start from 4. But originally we added 2. So we have to simply remove 2 before coming to next factor consideration. So this is a loop of factors. So current dot push the present factor, do the recursion for the factor, and then pop the factor that we added. So that for the next array, it will be simply empty array again. So hope you got this. Let's take the code. So simply answer initially int max because we already discussed, because the first one is also the best one. So when the first one will be best one? When the minimum difference initially is as max as possible. So minimum is equal to int max, and then current, which is initially empty, n comma 0 comma k and so on. We will discuss what are these. And then d is simply depth. That can be considered by k also, but let's add another parameter for more easiness. So d is the level. So if d is equal to k, it means that all k levels are done. That means all the array we got. And if d is equal to k minus 1, so we completed k minus 1 part of array. So only the last element is left. So that last element is simply n. So we'll update and then we will find the minimum and then we'll update the array. So let's check the code. So let's start with solve. So we are coming to this. And if d is equal to k minus 1, so what does this mean? It means that it is already, so k minus 1 elements are already filled in the current one. So only last element is left. So simply current dot pushback of n and then find the maximum and minimum elements of current. And if the minimum difference is less than the minimum so far, then update the minimum and update the answer also, because we got the new minimum difference. And then simply current dot pop back. Why pop back? Because this is exactly the case we discussed. Because before going to next one, we have to remove the one that we added for now. So we added n, so simply remove it. Because whenever we are going back to the function where we called, n should not be there, right? So simply pop back. So this is the case. And then start traversing through all multiples. So I is equal to 1 to n, I into I till less than or equal to n. So that we can do, root n. So if this is a factor, so if I is a factor, then push I into current, because we can consider this as the factor, as the index for now. So push this and then leave the rest for recursion. So simply solve n by I d plus 1 k. So instead of decreasing k, we are just using another parameter d. So n by a because updated in. This is the d level because we added a level at present. So the rest level will be d plus 1. So d plus 1 and k and so on. And simply current dot pop back. Why pop back? Because for going to the next factor, we have to remove the I we have added in this. So simply pop back. And then consider the other factor also, because we considered only I here. But n by a is also a factor. So consider this also. So if I is not equal to my n minus 1, it means that, for example, if n is equal to 100. So if n is equal to 100, if this is a perfect square, then I and n by I is same. So no need to do computation again. So if this not equal to this, then do recursion for this also. So simply if this is not equal to this, so push dot this and do recursion again and then current dot pop back again. So in this way we can find the answer. If you have any doubts, comment below. See you in the next video.